And it takes two of us to get the camera going.
All right. And what we do every day, we know that the students have to be able to know how to do things or understand things before they can do what we're teaching. And when they come to third grade, they should be able to understand place value, addition, as in bringing like things, like you're adding your tens together and your ones together and your hundreds together, and subtraction, separating like things. And what we do in the classroom is, what do my students need to know and learn how to do? So they have to add single digits, compose and decompose numbers. That means, instead of thinking of the number 23, you can think about it as 2 tens and 3 ones. So if you break it down into simpler numbers, we call them user-friendly numbers, it's easier to manipulate those numbers versus 346. You can break it down into its place value. Utilize strategies. We have numerous strategies for every single concept, and we'll get into that later on. Number sense, using a number line. We've used number line with multiplication. We've used it with division. We've used it with rounding. Now we're using it with adding, with addition. Partial sums, both horizontal and vertical. We'll show you what that looks like. In the U.S. traditional system is what we were talking about earlier, how you just put two numbers on top of each other and just add them, like we learned how to do it in middle school.
Won't go nowhere.
Okay, now that we kind of understand a little bit more about what the standard is, we're going to get into showing you some more addition strategies as well as some other examples and actually have you do something that'll help you understand what kids are doing.
It's moving slow.
All right, every morning we start our math classes with a number talk, and when we do a number talk, we have signals for those things. So we keep all of our numbers hidden, and the students have two signs. They can, once they see the equation, they hold their fist right here in front. And we do this because, you know, they might have some kids that are too shy to raise their hand or whatever. So they keep it right here in front. This means that they're thinking, okay? And whenever they have an answer, they give a thumbs up. And whenever they have another strategy for how they got that answer, they do this. And if they come up with another strategy, they keep going. But it's all right here, and they're not having to do all this. So if they're unsure of themselves, they put it right here so we can see what they're doing. So we're going to practice a number talk with you. So if you can show me what the symbol is for your thinking. What is it? What do you show me when you're thinking?
Good job.
What do you show me when you have an answer? Good. That was some good words. What do you show me when you have a strategy, an additional strategy? And what if you're a smarty pants and you have like 4 strategies? There you go. All right. So this is the first number, 25 plus 25. They are not allowed to talk. It's mental math. So I want you to put your fist up, you're thinking, and show me your signal and let me know you have an answer. So we'll wait until all students. Okay? Who wants to give me their answer? Not all at one time.
We have a student.
What's the answer? How did you get that answer? And see, but no, some kids. But see, and that's the thing. Some students will say that, but with us, we're like, okay, it's good that you have the answer, but you got to know how you got the answer. So that leads them into math talk. So if somebody can tell me, how did you know that 25 plus 25 equals 50? There you go. She's making a real world connection. 2 quarters makes 50 cents. And we'll make sure we bring that out too. So then we'll go to the next number. Okay, who wants to give me the answer? Why don't you give me your answer? How did you know that?
Just based off the last one, 2 quarters equals 50, then it's that again, that you have 1 extra.
Right. And that's what we try to get the students to understand too, if 25 plus 25 equals 50, right? This number right here is basically the same thing, except for 26 is just one more number. So you just add one more to the previous sum. Okay? Alright, anybody want to give me that number, the answer? Who said it? How'd you get the answer?
Took one away from 25 and added one. So 25 is 50.
Where did you take that one away
It's
from?
from 24.
You took one from 24?
And then added one from 26.
Okay? Relating it back to the previous
Right.
equations, okay? Now the last one is our favorite.
Okay.
Show them the last one, Mr. Perry. Four people? Alright, what's the answer? How'd you get that answer? How'd you get 75?
Well, I just went back to the traditional 25 plus 49 and 9, 6, 15.
You want you? Don't you got me the shot?
So she did the traditional in her head. Did anybody do anything different? She did the traditional method, the 24, the 26 plus 49, kind of like you were stacking it up on top of each other in your head.
You take, 1 from 26 and add it to 49, and makes 50. That's how I did it.
Mhm.
So that's 75.
Right, so you're putting them in friendlier numbers, okay? Those are strategies that we try to teach the kids too, because just because she did it one way doesn't mean that that's the only way that you can do it. You got to do what's best for you.
You ready?
These are some of the strategies that we've been teaching in class. Like I said earlier, finding those friendly numbers. This is like 200 plus 100, and you guys will get this handout too. Finding friendly numbers, using expanded form. I know my classroom, a lot of the students are really enjoying using this form because it just makes it easier to understand for them. Base 10 blocks, base 10 pieces, which we have some of those for you to use tonight as well. The number line, the traditional method, you've all seen that before. And all partials, and we call it partial sum. And once again, the reason why we use all of these methods is so that everybody has a different way of grasping the concept, and everybody understands, because not everybody learns the same way, not everybody processes information the same way. So this helps all students pick which strategy works best for them so that they can be successful.
And this is actually what we're doing now. This is one of the addition strategies that we're using. This is for them to see it concretely. And basically what that means is, back when all of us were in school, it was basically the teacher says, do it this way, and you don't question it, you just do it that way. And so many children just sat there and never knew, and I was one of them, never knew why am I carrying this one? Why am I doing this? So if we show it to them concretely, that gives them something, a picture or a manipulative in their hand so that they can actually move that manipulative and see, okay, well, that's why I'm carrying that one. I made a new group. Third grade teachers have 68 sharpened pencils and 28 unsharpened pencils. How many pencils do they have in all? And what we would ask them to do would be to set up this problem. And we would ask them to set it up the traditional way. And then either they would have those manipulatives in hand to use the way she's moving them on the screen, or the children also know how to draw these. So they would draw, we call them 10 sticks. They would draw 6 10 sticks to represent this number. And then 8 ones. And then for the 28, you would have 2 10 sticks and 8 ones. And something else that I do with my kids, I'm sure everybody else does as well, I actually have them to draw a line or something, a wiggly line, something between them, just to still keep them separate, because, you know, some kids have better motor skills than others, and some of these lines get a little long sometimes, and some of these might be a little short. That's just a way for them to keep them separate, the tens from the ones. And then, of course, we have them come back up and add them. Well, this is where they get to see, okay, I know that the largest digit that I can put in any place value is going to be a 9. I can't put 2 digits there. I can't put a 10 there. So when they come here, they say, okay, I have 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh no, I can't write 16 here. What do I have to do? This gives them that concrete. This is where that group of 10 comes from, that one that I carry. So I'm going to take 8, 9, 10 of these, and now that becomes a new group of 10. That's that one that I carry. And let's see what I have left in the ones. 1, 2, 3, 4, 5, 6. And then now the 10s. 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is so much more concrete than when we were in school. And if you just think back for a moment, you can probably remember your teacher saying, all right, you know what 8 plus 8 is? That's 16. Now you carry that 1 and you put that 6 underneath here. And we probably, if we think back, we might not even realize, hey, I really didn't know what I was doing. But that's the whole purpose in us using these manipulatives. And I tell my children, and I know Michaela's mom probably heard this, and Lauren's grandmother, anything at home, macaroni noodles, pennies, anything that they have a lot of that they can use as manipulatives, it doesn't have to be fancy. Just anything that they can manipulate to get their hands on, it will help them with the concrete ideas. All right, another strategy that she mentioned that we're using is called an open number line. Anybody dare to take a guess as to what an open number line is? Did you?
See, you can do both. Can't get both.
Okay.
I'll show you the main move.
Show you the Jeopardy board. Come on, you know this. Come on. Go ahead. Okay, I got you. All right, same problem. We're just showing it a different way. This time we're going to show it on the number line. What I tell my children is, we're not always going to be adding two digit plus 2-digit numbers. So I said, choose, they know the vocabulary problems now. I said, choose the largest adding. That's these guys, the numbers that you're adding. I said, choose the largest adding, and in this case it is 68. And then they also know the word, you guys have probably heard them say it, decompose. They decompose a number, they break it apart. So they're going to break apart that 28. Instead of trying to add this all at once, they start with the largest add-in, and then they chop this number into smaller pieces. This is how I tell them to think about that. If I handed you a cheeseburger, you would not stuff that entire cheeseburger in your mouth at one time. You would chomp it up into smaller bites that you can actually swallow. And as we get deeper and deeper into the math, they're going to have to be able to chop these problems up into smaller pieces so that they can be successful at them. So even though these may seem relatively simple, as we progress into those 3- and 4-digit numbers that we're going to be adding, they're already going to know how to manipulate them. They're going to know how to break them apart. So we're starting small. So we take this 28, we chop it up. Friendly number that we can use, 10. Tell them all the time, use your good friend 10. Most of these children can skip count from any number starting at any number by 10, so they automatically know 68 plus 10 is going to give you 78. 78 plus 10 is going to give you 80. That's an easier concept for them than to try to whole chunk at once. Well, how much more do I have? I still have 18 here, so I'm gonna make another jump of 10. Now I've moved 20 on my number line. Add 10 more, that takes me from 78 to 88. And I always ask them, okay, am I done? No, that's why I said you're not done. You still have 8 from your other add-in that you have to put in. Okay, let's do one more little jump of 8. And that takes them to 96. Now, some of my children might even break this 8 down even farther. They might say, okay, well, I'm going to get this to an even number that I'm comfortable with, so I'm going to take 2 from here and make this an even 90, and then add the 6 that's left to get to 96. Because even for this, the 8 and 8 may still pose some problems. And right here, it just gives you kind of what we're doing, decomposing that number, breaking it into those bite-sized pieces. All right, this is probably the one that gets the most grief to the children and parents. This is our partial sums. This is the horizontal. Same problem. We take our 2 add-ins, 68 and 28. This looks a little different than my kids. And we're breaking these numbers up, and I make mine ladies also. Ones, tens, and then today we started 3-digit numbers, so hundreds. We break that number apart. Well, how many 10s do we have? We have 6 10s. But instead of putting a 6 there, I say, okay, I know we have 6 10s, but what is the value of those 6 10s? Exactly, so then they know, okay, the value of 6 10s is 60. And then how many 1s do I have? I have 8. You see that have a little plus sign. Same thing here. How many 10s do I have? I have 2 10s. What's the value? The value is 20. 8. And of course, they add their 10s. And they add their 1s. Like I said, you can break those numbers down even more if they needed to. If they needed to then come and break this, decompose this again to be able to get it, they can do that as well. Alright. This is the one that's just a little more difficult to understand. This one is the vertical. And basically that's exactly what it is, vertical. It's up and down. Instead of going side to side, like we just did, we're going up and down. So they took 8 plus 8 out of my 1s, and it makes 16 1s. Then the children come beside them. 8 1s plus 8 1s equals 16 1s. And in their notebooks, we have them actually write all of this out, because they have to be familiar with not only the numbers, but the word form as well. Because whenever they get the pass test at the end of the year, we don't see that test. We don't know how it's going to be shown to them. So they need to be familiar with all of these different ways. Then you come to your 10s. I have 6 10s and 2 10s. That gives me 8 10s. Well, what's the value? The value is 80. Put my 0 there. Because, and you guys may have already seen this at home, a lot of times with the traditional method, if those kids don't have these things lined up where they belong, this 8 may end up over here under the 1s instead of under the 10s where it actually needs to be. And then of course they come out again and write, I have 6 10s plus 2 10s, that equals 8 10s, or 80 1s. They also have to understand that. Like you can trade one for the other, vice versa. And then 80 plus 16 the value you had for your partial sum from what you added for your ones, and your partial sum from what you had for your tens, added together to give you your sum, your total. All right.
Right there on top of the box. On top of the box. We don't have that one. That's the topic. Oh, okay. You want me to keep going? You want me to keep going?
No, just say there. I'll do it. All right. Charter Intermediate has 138 third graders and 295 fourth graders. How many students are in the third and fourth grades? All right. Partial sums. So let's start with the traditional method. So that's what most of you are going to be most comfortable with. So I'm going to write tradition. How many hundreds do I have in my first add-in? Remember, my add-ins are the numbers that I'm adding together. That's one of my babies, by the way. How many hundreds do I have in my first add-in, Miss Laurie? I have 100 because that is the value. Remember, value. I have 100, but the value of it is 100, right? So in my hundreds place, I have. In my tens place, in my first add-in, how many tens do I have? How many tens do I have? In my first, the very first one, 3. Here you go. I have 3 tens. How many ones do I have in the first add-in? All right. Second add-in. How many hundreds do I have? 2. 2 hundreds. How many tens? 9. And how many ones? 5. All right. Now, all right. So the first thing we have to do is what, Lauren? Got to add your ones because this is the traditional method. This is the old school. This is how we learn. So 8 plus 5 is 13. What do I do with that 1? I carry the 1. Now there is one little thing that looks a little different now. You can either carry the 1 on top, or for some children it's actually easier for them to see it if you put the 1 underneath. Either way, same difference as my granny used to say, same difference. So on top or on the bottom, we're going to see that little guy on the top. Okay. What am I doing here? 13, so I'm going to have to do what again? I have to carry, I'm going to have to regroup. That's something else. Back when all of us were in school, I said you got to carry that 1. Now it's called regrouping because you're taking a group of these 1s, making a new group of 10s, or you're taking a group of 10s and making a 100. All right, so I have to regroup again. What do I have, Miss Lauren? 13. So I have to do what? I have to carry my 1, regroup, and then that's old school. That's the way we all learn. It works just fine. But do you understand that the difference now and then is just that we are trying to let them see the concrete reason why that 1 goes over there. That's where those base 10 blocks come in. All right, now partial sums. Partial sums for this. Atkins again, 138, 295. ones am I gonna need? And Lauren said 4, she's counting. All of that, put these in. All right, so there's my hundreds, my tens, and my ones. Raise your hand if you think you can tell me what expanded form means. Expanded form. What'd you say, Grandma? You're stretching that number out. That's what I tell my kids. It's like stretching a rubber band, and that's exactly what I do with them. I say, well, you know, we stretch it out, and then we let it go. So, hundreds. What's the value of the digit that I have in my hundreds place? That is the value, 100. What's the value of what's in my tens place? 30. What's the value of what's in my ones place? 8. All right, my second add-in. What is the value of what's in my hundreds place? 200. What's the value of the digit in my tens place? 90. And the value of what's in the ones place? 5. And then again, the kids would say, okay, I'm only looking at my hundreds. Remember, this is partial sums. What's the word partial mean, first of all? What does that even mean? It means part of. So we're not looking for our sum, yet we're looking for the parts of our sum. And then we let them all go. We let the elasticity out and we just pop it back together. All right, so in our hundreds, what's the value of the digits that I have in my hundreds, or the two numbers that I have in my hundreds? 300. How about for my tens? Which kind of poses a little problem here, doesn't it? Right? I have 12 tens here. So this is where my regrouping is going to have to come into play, right? Same here. My 5 and my 8. What's happening here? 13. So this is why, and I'm going to leave this like this. I'm not going to finish this up because we just did the other one. But do you understand why, if they don't understand this concretely, how this could be confusing for them? It's a wonder we got through it and we're able to understand it. So that's why we started out with the concrete, and then we have moved. Now, once your child gets to where they're comfortable with all these, and if we throw it on a test, they're going to be okay with it. If they solely solve, unless it says otherwise, if they solve using traditional, that's going to be fine at some point. But for now, they need to understand doing these partial sums.
Okay, we're gonna play a little game, or we're gonna show you a game. Most of your partners will tell us where. This is one of many games we're playing in class. I know Miss Bryson said, you know, when we were going along, we rarely played games in math class or in school period in class. And I'm from old school, and that has been a hard thing for me. But I do believe, you know, the more we've done this, that the children, if it's, as long as it's got a skill with it, like adding or multiplication, or as long as it's a valuable skill, that all they'll see is that they're having fun and they're just repeating that skill over and over again, and they don't even know they're repeating the skill. They're just having fun doing it. So this is called Addition Topic, and you may see some other topic games come home. Topic just means I have more than you, or you have more than me. You're trying to top the other person. You know, you're trying to get more. So what we're going to do with this one is you'll have the kids, or we have a pack of cards, and they would pick cards, and you'll form a 3-digit number. That's what this one is. You can do it with any amount of numbers. You can do 2 digits and 2 digits, or up to 6 or 7 digits. depending on the group of your children that you're working with. And then they would, like, I'm gonna do, two numbers, and you'll do two numbers, and then we'll find the sum, we'll add them up. And I can use this strategy, I can use whatever strategy I want to use that I'm most comfortable with. And then, of course, play with the largest sum wins. And back to what Ms. Bryson was saying about, how eventually, you know, if they can use the traditional sum or the traditional method, that's wonderful. One thing we try to teach them a lot right now is what is most efficient. And what might be efficient for you might not be as efficient for me. Like earlier when Ms. O'Neill said she did the regrouping in her head and she added 49, 26 in her head. Well, if she can do that, that's awesome. But some other children may not can do that. So what is efficient for you may not be as efficient for me. But we also try to get everybody to the most efficient way. Because it's more efficient for me to learn 8 times 7 is 56 than for me to sit and have to draw 8 rows of 7. That's fine as long as I'm learning it. But our goal is fluency in adding and subtracting and multiplication. Anyway, so we're gonna you'll find a partner. If you're using a rating deck of cards, and that's what we have, you know, a lot of times we will make, like face cards have a different value. And once they play something a time or two, they've got that memorized before we ever do, you know, they can memorize stuff like that. So, like on this one, aces are 1, kings are 0. And, then if you get the other cards, just toss them out. You know, like, if I'm player A, you're player B, you would, and you can pick those cards, put those cards wherever you want as far as your numbers. So, you know, you can kind of manipulate how large your number is that you're making as you pull your cards. Yeah, you're A and she's B. Anybody else need that?